These arrow diagrams are a little bit harder to determine whether something is a function or not. Okay, but basically what we're looking for is this 1 to 2 issue. Okay, so here we have two elements that go to 1. That's okay, because that means that we have two different x's, or that goes to the same y value here and here. Okay, that's okay. That passes a vertical line test. That's not a problem. Here, same thing. We have 2 to 1. Okay, so that's okay. These are considered functions. What we're looking for, though, is this 1 to 2. Okay, this is a problem, because now if I have 1x, I end up with two different y's. Well, that does not pass my vertical line test. Okay, I have points stacked on top of each other. That does not pass a vertical line test. So this is not a function. So this is what we're looking for. When we have graphs, we're looking for the vertical line test. When we're looking at these functions, these arrow diagrams, we're looking for 1 to 2. So here we have 1 to 1, 2 to 1, 1 to 1, 2 to 1 is okay. It's that 1 to 2. So this is a function. Okay, and this concept of function is important because we want to have relationships are very important, but functions are even more important because it allows us to have one input that maps onto one output. Okay, and we don't have one input mapping onto two outputs, because that becomes a problem when we have functions, because we don't know, when we put a number in, we don't know what we're getting out. So when we talk about functions, we want to use this model called a function machine. Okay, where we have this kind of input, that's our domain. Okay, input, remember, goes with our domain. And we put that input through the function. Now something happens inside there. We don't really, sometimes we know what it is, sometimes we can come up with a rule, sometimes we can't. And it gives us one output, which is part of our range. Okay, and this is what we're looking for. And this is a model we use. We use this function flow chart to do it. We put something in, does something, we get something out. Okay, so here we have an input of 5. So I have my input of 5, which I'm going to just highlight in red here. These are all what I put inside. Okay, there's my input. I input 5. My output is 8. That's my range. Okay, so this represents my range. So if I input 7, I get an output of 10, input of 8, output 11, input of 12, output of 15, input of 20, output of 23. Well, it seems to be a pattern. So sometimes we can figure out patterns, sometimes we can't. In this case, the pattern looks fairly obvious. When I input 5, it looks like I'm adding 3. Input 7, add 3, I get an output of 10. So it looks like I can predict my output based on my input. And if I can do that, I can write my function in this way. So my function basically is going to take my x and I'm going to add 3. That's what my function is. It's a +3 function. And so if I can do that, my rule then is my f of x, or y, is the output y is equal to x plus 3. And there's this new notation that we're going to use. We're just going to write this as a function of x is my output, my y, and I get my y by taking my input x, and I'm going to add 3 to that input. And that's my rule for my function. It's a plus 3 function, okay, or an x plus 3 function.